Hello, my name is Maria Rose Buez. I'm a master graduate in information security and forensics from the Arab Open University. In a recent study, it was shown that the average person touches their phone up to 2,617 times a day. And these smartphones are like a mini computer in our pocket. For instance, when I finished my presentation, I sent it to my friend and they all checked it through their phone. So, our phones do not only contain our own information, but also files and data from people we come in contact with. All of this makes a mobile device a data mine in any criminal investigation, considering the vast range of information that can be retrieved. In the following presentation, we will go through why Android was picked ahead of iPhone and the importance of routing in an Android data acquisition. We'll start off by an introduction to Android, its architecture and security. Then we will go through both logical and physical acquisition tools, why routing and how can routing be done. Then we'll go through a case study on a Samsung Note 4 and an analysis of the data acquired. Android is a Linux-based operating system. It was developed by Google and later by the Open Handset Alliance. The first Android mobile was announced in 2008, collaboration between T-Mobile and HTC. Android is the first complete, open, and free mobile platform. Since the first Android phone was released, sales have skyrocketed. In May 2012, Android became the most used operating system in mobile devices. Fast forward to March 2020, and Android market share worldwide reached 72.26%. Android has many advantages. For instance, if you allow unknown sources in your settings, you will be able to install third-party applications. Applications that usually are paid, you can download them and install them for free. Also, the easy file sharing between Android devices through Bluetooth or Wi-Fi direct. And then we have many choices of Android devices considering the vast amount of manufacturer, and each of them have a model with different price range, which means that there is an Android device for every person from any social status. So all of this means that it's very probable that the phone being investigated will be running Android. So it's logical for us to study data acquisition on Android running devices. Android consists of four major layers. At the base, we have the Linux kernel that consists of all the drivers, from audio drivers to camera driver, in addition to the memory management and the process management. These are responsible for allocating enough memory for our application and for the multi-process communication. At the top of that, we have the Android runtime layer, which translates the written code into machine codes. In addition, we find here the native functions and libraries. After that, we have the application framework. Data services available on this layer, services that developers can call to use in their own application. In addition, we have the activity manager, the content providers, and both telephony and location and notification manager, which basically are the ones responsible for our GPS, for our calls, and our notification. At the top layer, we have the application layer. This is the only layer that the user come across in direct contact with. In this layer, we find the application that the user installed from the Play Store, in addition to the application that comes with the phone, like the clock, the alarm, and the contacts. Android relies on three major security mechanisms. We start off by the lock screen protection, then we'll go through both hardware encryption and data protection. The passcode protection consists of a pattern lock. This is a pattern design that the user needs to replicate in order to unlock the device. A PIN code which consists of 4-digit number. The passcode, which is alphanumeric, takes a combination of numbers and letters. After that, we have the biometric passcode protection. We start off by the fingerprint, where the user can use his own finger or someone else's finger to unlock the device. In addition to the face recognition, which uses the front camera and compares the image with the one saved in the phone. Also, the iris scanner that scans your iris and compares to the one stored in the device. How to bypass this passcode? Passcode is the first obstacle we face as a criminal investigator. If we don't get past this passcode, we can get through the criminal or the data of the person. The first method is the smudge attack. Now, if the user or the device owner had the pattern lock at a certain angle and with certain lighting, we can find the oil residue from the finger on the screen and we can replicate it in order to unlock the device. The second method would be through the Android debug bridge, which requires a rooted device and USB debugging enabled. The third method, it's a paid solution offered to us by Dr. Phone Unlock. The first method would be a custom recovery mode booting, which we can use the TeamWin recovery project in order to unlock the bootloader and install a custom ROM. Now, if all these software-based methods fails, we only can do a GTAG or a chip-off. GTAG or chip-off consist of using the hardware of the device in order to retrieve data. The sixth method would be using the Xpin clip, which is a device cap that can brute force the password or the PIN on our device. But this only supports up to Android 6. We'll go through the logical acquisition tools, which is a bit-by-bit copy of logical storage. No root is needed, and this method can retrieve SMS, call history, application data, GPS, and media. The first method would be using the ADB pull command, which allow us to pull every folder on its own. If we know the location of the file we want, we can assign it to pull this exact file. As for the ADB backup command, it will create a full backup of the device in our hand. Many third-party applications exist, like the AF Logical OSE. It will grab information from all contact providers, but this means that we need to install this application on the device in our hands, and we select the data we want to capture. Routing. Now, what is routing? Routing gives us a super user privilege on the device in a way that it gives us full control of the device in our hand. There are many one-click routing apps that works on most older Android version. Application like Kingeroot, PharmaRoot. This application needs to be installed on the device, and with a single click, we root the device. A third another method would be using Dr. Phone Root, which is an application we install on our computer. And by putting the linking the device to our computer and clicking root, it will simply root the device. Now, if this method fails, the only way it would be by flashing the device. Anyway, we need to have USB debugging enabled or an unlocking enabled. After that, we can unlock the device bootloader, and then after we boot in fast boot mode, and then by installing the TeamWin recovery project, it will allow us to install a third-party firmware. Physical acquisition tools. Physical acquisition is the extracting of an exact bit-by-bit copy of the original device flash memory. It will allow us to acquire unallocated space, files, and even deleted data. This method, though, and tools requires a rooted device. We can do this by the dd command, which after we connect the rooted phone to our computer and using the dd command and inputting the input folder and the output folder, we will have a physical image of the device that can be put on the SD that we inserted in this device. And then this SD card can be put on our computer and analyzed. The GTAG technique, which is named after the Joint Test Action Group, which codified it. It's a way to verify design and test printed circuit boards after their manufacturing. We can use it to extract data even if the phone has a lock screen. It will require the assembly of the device though, but can be used even on a damaged device. But this method is not allowed by some manufacturers. The chip-off technique should be our last option, as it will have the NAND flash chips removed from the device and examined to extract the information. This works on devices even with passcode protected. It will work even if USB debugging is disabled, but the device is usually destructed after this method, and it will be very difficult to attach the flash. So this requires an expert in addition to costly acquired equipment and tools. A case study will be done on a Samsung Note 4 running Android 6.0.1. There was no lock screen, and the factory reset was done by the last owner, and the device was used only shortly after that. At the first step, we will perform a full backup of the device without any change made to it. No rooting, no factory reset, or any deleting. At step 2, we will root the device, and the physical acquisition will be done using DD command. Step 3 will be analyzing the result using Autopsy and the DB browser software. At step 4, we'll compare both analyzed data, and we'll see the important role routing has in our forensic examination. Step 1, the logical acquisition. We'll first start off by installing the ADB driver with USB debugging enabled and the device connected to the PC. Then we will input the ADB backup command, and we'll assign it to backup all the device. After that, a screen will flash on the device at hand that will ask us to back up my data. The result backup file need to be parsed and extracted. The copy can be done through this command. The image that we acquired then is analyzed using Autopsy. We'll see straight away that the data found are the data only currently available on the device. We'll see that we have a little bit over 2,000 images, a little bit of videos, and some audio. Now, though, if we do a search for longitude, we will find a GPS location on this device from the weather application. Now, because the data wasn't organized well, we needed the DB browser for SQLite to analyze the DB file, the database file of every application in order to acquire some relevant data like last calls or so. But this means we saw no trace of older data, and only data currently available on the device was managed to be pulled. At step 2, the physical acquisition. First, this device has USB debugging enabled and is connected to our machine. Now, we root this device using the Doctor Phone application root. Now, we insert a clean SD to the device. And through the command line, we input ADB shell, which will allow us the full control of the device at hand. Then we use the SU command, which will give us an elevated root access. Now, we will use the mount command. Why would we need the mount command? In order to find the data partition and the SD card path. In the following screen, we will see that the data partition was available in this ext4 file system type, and the SD card storage is under storage. After that, we will input the DD command that will have the input folder as the data partition we found with the mount command, and the output folder, the SD card location. After waiting some time, a physical image is created. This image can then be copied to our computer and analyzed through Autopsy. At a first glance, we will see the huge difference. Now, instead of 2,000 images, we have over 31,000 images and over 1,000 video and 3,000 audio. In our case, we needed to find a certain call made by this person. Now, this call was done prior to the factory reset. So in our logical acquisition, we weren't able to pull any data on that. Now, in the physical acquisition, we managed to pull way many data. So going through this third-party application folder, we found an application called CallX. This third-party application records calls made by the user. Now, by calls, we don't mean WhatsApp calls or any other application calls. We mean the calls done through the network carrier. Now, going through this application, we were able to find the call we were searching for that was done at a certain time. And thanks to this application saving the calls in MP3 format, we were also able to listen to the call done by this person. Now, we saw that physical acquisition allowed us not to only pull data present on the device, but also all data that has been deleted. And it was easier, much easier to analyze the data, considering how categorized they were, which show us that in a logical acquisition, even though no routing was done, the data that we were able to acquire was only the data available on the device. So now in case of the user or the culprit factory reset the device, no such data whatsoever will be pulled. Now, if in the case of the lock screen that isn't easily bypassed by the method we shown before, no data will be pulled. So now in the physical acquisition, routing was needed, but this allowed us to pull even all deleted data in addition to system information. Now, this means that even if the user did a factory reset, evidence will still be pulled. And also, if the lock screen was so hard to manage and be bypassed, and we required us to unlock the bootloader of the device, which will cause all data to be factory reset. Through routing it and doing the physical acquisition, we'll still be able to acquire most deleted data. So our conclusion, mobile forensics and investigation are evolving to keep up with the security progress being imposed by Android operating phones. A lot of data extraction relies on routing though, a technique that isn't always easy to perform, and in many cases not only affect the data integrity, but it can also break the phone. So it's very crucial for investigator to understand the system being investigated for them, so they can choose the right tools and method to perform the forensic examination. So it shows us that in a physical acquisition, this cannot be performed without rooting the device. And rooting the device is the only solution for us in many cases to acquire any sort of data if the criminal or the old user of the phone tried to hide data by factory resetting or by imposing a very hard lock screen to bypass. Thank you.